maximum minimum. This maximum minimum already we discussed actually. If you
Yes, sir. I have the notes for maxima minima.
maximum minimum.
So you given notes, no? I have that for maxima and minima.
Yeah, yes. Maximum minimum. So anyway, just I'm going to revise once. So here, what is maxima and minimum? Maxima and minimum. So this is only revision. So yeah, later you can go through the video, other video we have. So anyway, so here what is maximum minimum? So if see y equal to f of x is a function, right? So here this function, as we give x values, this function will get its value, right? X value, then you get y value. X values we take on x-axis and y values we take on y-axis. Let's say now we have a curve like this. So here, as you give x value, this is y value. This is x value, this is y value. Okay, here x value and this y value, this x comma y. And as you give a x1 value, then you get y1 value here, this x1 comma y1. And like this, you get here x2. If you give, then you get some y2 value. Let's say this is x2, y2. And here, what you can say is here the point x is called point of minimum. Okay, point of minimum. And x is point of minimum. And what is y? Y is minimum value of the function. Yes, sir. Minimum value of f of x. So let's say this function is f of x. This function what I drawn is f of x. Well, yeah. So then next, and what is here x2? X2 is what? Point of maximum. Point of maximum. And f of x2. When you substitute, because this is the point of maxima, when you substitute x2, you are getting some y2 value. Okay, this is what is maximum value. Maximum value. F of x2 is its maximum value. As simple as that. That means what? Every function attains minimum and maximum values. But sometimes, see, now y equal to x square is there, and this function is like this. Okay, symmetric over y-axis. And now here you see minimum value is 0, but maximum is what? Infinite. So that's how we say maximum is not defined. Okay, but every function has minimum and maximum. So we need to, so this chapter is that we have to find out that minimum and maximum values. So then here to find out that we use derivative test. Okay, so what is that first derivative test? Let's see here first derivative test. First derivative test. What is first derivative test? So here, first thing is point number one is, so here you have, let's say like this, you have function is like this. Okay, I'll go like this. Yeah, maybe like this and yeah. Okay, I have like this graph. I have. Okay, I have like this graph. So here, what is first derivative test? You know, first derivative test we use to find local maximum, and local minimum. Local maximum and local minimum. This is first derivative test is used for this. Okay. So here these are called turning points. You see, these are turning points. These are called turning points. So first turning points. So at turning point, slope of the tangent. So here at these points, let's say this is some A. Let's say this is some point B. And let's say this is C. And let's say this is D. So turning points, what you can say, at turning points, f dash of x, that slope of the tangent is 0. That means what? Slope of tangent at point A is 0. Similarly, B, C, D. So these are the turning points. Now here, this is called local. That means what? In this region, okay, this is minimum. This is called local minimum. That means what will happen now if you draw the tangent here, you see slope of the tangent is what? So the slope of the tangent is negative because more than 90 degrees. So f dash of x, f dash of x. So you are at a in the neighborhood of a. That means a minus h from a minus h. That means what? Left side of h. A minus some small h is some small positive quantity. So a minus h means here in this a minus h is what? This is a minus h point. So in this all slope of the tangent is what? F dash of a minus h is what? Less than 0, obviously less than 0. And f dash of a plus h is what? Greater than 0. That means what? So now this a plus h means still here. So here if you draw now, what will happen? So its slope of the tangent is positive. So Harshika, able to understand? So that means what? You have slope of the tangent is negative to positive. It is changing. Okay, in the neighborhood of A. So that means what? In this, f attains what? F attains minimum. Minimum at x equal to A. Harshika, able to follow?
Yes, sir.
Slope of the tangent. So here at 0. At A it is 0. Left side of A negative. Right side of A positive. That means what? Minimum. So similarly, if you see in the neighborhood of B, if you see, so left side it is negative, right side it is positive. Okay, that means what? That means what? Here negative to positive, no? Sorry. This is positive, right? It's positive. Positive to what here? Negative. Okay, positive to negative. So like this. If you have maximum, then what you get? This is x-axis and this is positive. Slope is positive. Okay, this is point B we thought of. So f dash of b minus h is greater than 0, positive to negative. B plus h, that means first increased and then decreased, that means what? You get maximum at x equal to b. Like that. This is called local because this is only local. What is then absolute? So you have a curve like this, and then like this. You have a curve like this. Okay, I'll go like this. So this is what now if I draw in the interval of a to b, this is a and then this is b. In the interval of a to b, in the closed interval of a to b, now this point is what? This point is also this is minimum, local minimum. This is local maximum. This is local minimum. This is local maximum. In this interval, it is maximum. So in this interval, it is also maximum. See, in this interval, this is maximum. Okay, this interval it's maximum. Okay, this is also local maximum. So you see here, local maximum 1, 2, 3 points are local maximum, 2 points are local minimum. You understand? This is point, let's say x1. This is point, let's say x2. This is the point, let's say x3. So now here these are local minimum and this is local maximum. This is also local maximum. Now what I want? Absolute minimum I want. What is absolute minimum? A wala minimum. This is also minimum. But out of these two, x1 absolute minimum is at x1. And its value is f of x1 is absolute minimum value. And here what is maximum? Maximum is b, not x2. Maximum is b. Okay, absolute maximum. What is absolute maximum? Is b. Absolute maximum is at x equal to b. You get absolute maximum. And f of b, when you substitute in the function, you get its maximum value. Okay, this is about local minimum, local maximum, and absolute minimum, absolute maximum. And I told you first derivative test. That means what? First slope of the tangent is decreased. Okay, decreased. Okay, first decreased and then increased. That means minimum. First increased and then decreased. That means what? Local maximum. So how do you check? So left side f dash of left side, f dash of x is less than 0 to f dash of x. That means what? F dash of x is changing its sign. First you understand changing its sign means what? You should understand it will have local maximum or local minimum. So negative to positive means what? Negative to positive minimum. Positive to negative. So Positive to negative means what? It's maximum. That's what is first derivative test. Okay. And then next, second derivative test. Meryl, what is second derivative test?
If the second derivative is greater than 0, then
Okay,
it
first
has
of
a-
all, yeah,
Yeah.
at x equal to c, okay, at x equal to c, okay, at x equal to c, we are considering first. If f dash of c equal to 0 first, that means what? It's a turning point. F dash of c equal to 0. Yes, tell me. And f double dash of c is? Meryl, tell me what?
0.
F double dash of x for minimum.
It has to be greater than 0.
Yeah, f dash of c is 0 and f double dash of c is greater than 0. Then at x equal to c, f has minimum. Okay, and its minimum value is obviously its minimum value is f has its minimum value is f of c. Obviously, at c you have minimum value. So if you substitute in the f, then you get minimum value. Second one, if at all f dash of c is 0 and if at all f dash of c is 0 and f double dash of c is less than 0, then at x equal to c, okay, f has its minimum or maximum? Maximum, and its maximum value is f of c. Okay, I am saying either at C it will have either maximum or minimum. Understand? At C it is either maximum or minimum, but I am telling two cases. If it is greater, it is minimum. Lesser, maximum. Okay, then 3 is what? If at all f dash of C is 0 and f double dash of C is also 0, then what happens? Then test fails. Test fails. Then what you should do? You have to go to first derivative. Okay, you have to go to first derivative. What is that first derivative test? First derivative test is this. First derivative test is that. What is that? So if f is changing from negative to positive, minimum. So positive to negative, maximum. Okay, it doesn't change sign. Okay, third case is there. The second case, if f dash of x doesn't change its sign, doesn't change sign, then what we say, we say at x equal to c, is point of what? Meryl, what is this? If at all, f dash of x,
Inflection.
inflection. Point of inflection. How is it? It is always like this. It's like this. Point of inflection is like this. So what happens is sometimes f dash of c is 0. If you find f double dash of c is also 0, in this case, y equal to f of x is x cube. In this case, this is called point of inflection. If you draw, slope of the tangent is not 0 here, but you will get here 0. That means what? When f dash of x equal to 0, then you cannot say that is always a turning point or critical point. Sometimes it is point of inflection also sometimes. So anyway, that is there in the video once you can see. But now, as of now, this is the concept is enough to solve the problems you are going to. Yes, Meryl, how many problems did you do? We did till actually 3. Third problem we did. We found local maximum, local minima, and then absolute maximum, absolute minima. I explained about 5th question. Have any doubts up till 5th?
So I only did till 3rd, so I couldn't do after that.
All right.
I didn't have time to do after that.
Yeah, exactly. So no problem. Yeah. Just give me a minute. Chalo, so everybody, you start doing this. Chalo, fourth question. So we should complete today. Fourth question. What is that? Prove that the following functions do not have maximum or minimum. Doesn't have maximum or minimum. Chalo. How do we do this? Chalo, come on. Yeah. So, first question. How do we do it? F of x is e power x. Doesn't have maximum or minimum. How do we do this? So we'll apply second derivative test. First, always we should apply second derivative test. Always you apply second derivative test. What is that? F dash of x is e power x ka e power x equal to 0 to find critical point. So e power x is 0 is possible. E power x is 0. That implies what? X. Okay. Not possible, right? F dash of x 0 cannot be, is not possible. That means what? No turning point. So what does it mean? No x value. You understand this? No x value. What does it mean? So actually, if you see e power x graph, it's going to be like this. So that means what? E power x. See, if you see e power x, what happens here? E power x as x tends to actually this is 0. Okay, as x tends to minus infinity, and already I told you, as x tends to minus infinity, e power x tends to 0. You understand? It's not 0, tends to 0. And as x tends to plus infinity, e power x tends to infinity. That means what? 0 to infinity, e power x belongs to. So you cannot say minimum, you cannot say 0, because 0, it doesn't take 0. In infinity, it doesn't take infinity. Therefore, what you can say, that is the reason it's not having any turning point. It's going infinity and it's going infinity like that. So therefore, e power x. So prove that. What we have to prove here? There is no turning point. Okay. So here f dash of x is 0. No, I'm sorry. What is it? F dash of x is not equal to. F dash of x is not equal to 0 for all x belongs to R. So therefore, f has no maximum or minimum. Same thing, log x is 1 by x. 1 by x, log x is what? 1 by x, there is never 0. F dash of x, g or whatever. In this case, g dash of x. In this h dash of x, there is all same thing. Hope you understand this. Are you all clear?
Yes, sir.
Yes, sir.
So chalo, next fifth question, let us go to fifth question and do it. You try, fifth question you try. So here already I told you that when you have the interval, so here you have interval in this case you see. So what is that interval you have here? All questions are given some interval here. So you need to find out absolute maximum, absolute minimum. I'll do 1 or 2 questions here, then you can do the remaining questions you can do. Okay. So first question, first question. What is that? F of x equal to x cubed. Okay. Then you see x belongs to minus 2 to 2. So how do you do this? Okay, in detail we'll have to discuss this. F dash of x is what? 3x square. You have to first equate to 0. If you equate to 0, you get x equal to 0. Then what you need to do here, x equal to 0, 1 point and minus 2 and 2 are the other points. These are the critical points. These are called critical points. Here, learn this. End points always critical points, and this minus 2, 0, 2 are critical points. That means what? At these points, you will have maximum and minimum. Very simple. So that means what? Now you first find f of minus 2. What is f of minus 2? Minus 8. F of 0. What is f of 0? 0. And then f of 2 is what is 8. You know what is this? This is asking to just find absolute maximum value, absolute minimum value of the function. This is what is absolute maximum value. This sorry, absolute minimum value, and this is what is absolute maximum. Yes or no? This is how you have.
Yes, sir.
So this is how you have to find. That means what you got is you got here one point you got where you may have critical point. That means what? Where you may have maxima or minimum.
Here we don't need to do second derivative test or anything.
Yeah, don't need to do second derivative test. We don't need to do second derivative test is only for finding local maxima and local minimum.
Okay.
So here what you are getting is critical point you are getting that at those points, at these critical points you will have maxima or minimum. But if I substitute in the function, I will understand. Na? It will have either local maxima or local minima. But second derivative test, you check to find out whether it is local maxima or local minimum. You understand? But in the function only I am substituting it. Got it? Now I got the critical points. At 0, now critical point I got 0. At 0, whether it is local maxima or local minima, I have to check, means I have to go for second derivative test. But I am substituting only. Na? Here -2, 0 and 2. These are the 3 points. At these 3 points, I will have local maxima or minima. That means 3 points I am substituting. Then when if I substitute 3 points, I am getting here from this answers only I can decide. Na? Yes or no?
Yes, sir.
Yeah, like that. So, chalo, next question. So, next question. Next question. Second. What is the answer? Second question. F dash of x you need to find. What is that? Minus sin x. Yeah. Yes, f dash of x. You have to equal to 0. Yes, 2 quadrants. So cos x equal to sin x. 2 quadrants only. So cos x equal to sin x is possible in the first quadrant or not?
Yes, sir.
How much?
5/4.
Second quadrant, is it possible cos x equal to sin x?
No.
Sir.
Huh?
No.
Only for 5/4 it is possible. In the third quadrant it is possible. Again in third quadrant it's possible. Now x equal to 5/4. Now here 0 comma pi is also there. Na? Here one critical point you got. That means what? Now x equal to what? 0 comma 5/4 and also pi. These are critical points. Okay, at these points we'll have. So now we have what you need to find? F of 0. F of 0 is what? 1. The next f of 5/4. F of 5/4 is what? Sin 5/4. 1 by root 2 plus cos 5/4. 1 by root 2 is what? 2 by root 2 is root 2. And f of pi is what is again? F of pi is what? 0 comma minus 1. Is minus 1. 0 plus minus 1 is minus 1. Where is this is what? Therefore, what you can conclude? Minus 1 is what? Absolute minimum. Plus 1 is what? Nothing. This is 1.4 something you get. No, this is absolute maximum. So therefore, this is point of maximum, this is point of minimum. But he asked only absolute maximum, you need to find out absolute minimum, you need to find. So absolute minimum is minus 1, absolute maximum is root 2. That's enough. Is that okay? You got it?
Yes, sir.
These 2 questions enough. Can you do 2 more?
Yes, sir.
All right.
So even for the other two, we just find the derivative equal to 0, find the other critical point, and then check, no?
That's it.
Yes, sir. Done.
Yeah, because see, I told you, no. I again going back. See, I told you right here. Here I told you. What do you get by f dash of x is 0? What do you get? You get x1, you get x2, you get x3, you get. and end points. Okay, got it? By f dash of x equals 0, what you get? x1, x2, x3. Why? Because these are the turning points, yes or no?
Yes, sir.
Then along with that, what you have to check? A and B also you have to check, yes or no?
Yes, sir.
But if you check now, let's say you got here y1, you checked here y1, you checked here y2, you checked here y3, you checked here y4, you checked here y5. Okay, by this values, can you decide which is bigger and which is smaller? Turning points is good enough. Now for that you have to do f dash of x equals 0. So now you got 3 points plus 2 more points also you have to check, because these are also points of maximum and minimum. So therefore now you got, so by this what you can understand, y5 is maximum. Okay, and then y2 is minimum. Absolute minimum we got, absolute maximum we got. That is what we are applying. Got it or not?
Yes, sir. Got it.
What, Rishita? Rishita, I'm not able to hear you.
Can you hear me?
Find maximum profit that a company can make if the profit function is given by this. Maximum profit means what you have to find out its maximum value. That's direct. How so easy? This is p dash of x is what you know, minus 72 minus 36x equal to 0. You understand? Equal to 0. Then what you get? Minus 72 equal 36x. X equal to minus 2. That's it. At minus 2 will have definitely maximum, because only profit only is asking what maximum profit is asking. So only x equal to minus 2 is a critical point. At this 2 only, at this minus 2 only, you should have maximum. How do you know? P double dash of x you find. What is that P double dash of x? Eval 0, eval minus 36. Less than 0, na? At minus 2 or whatever. It's less than 0. That means what? Double dash is less than 0 means it will have maximum. So therefore, at minus 2, it will have maximum. But how do you find its maximum profit? To substitute here 2. Minus 2 substitute here. 41 minus twice of this. Okay, you'll get it. Okay. Find both maximum value and minimum value of this function on the interval 0 to 3. Do it. Let's see.
But this is the same as the fifth one, no?
Very good. Correct. Correct. But here, how many points you get, you know? Here, because this is 4th degree, you get 3 critical points plus 2. The graph I gave, no, that's how you get it.
Yes, sir. Sir, but it isn't difficult. You just find the derivative and then
Yes.
it is 0.
So 3rd degree, how do you do 3rd degree? How do you factor 3rd degree? Because you need to get equal to 0 and factors and do the roots. How do you get?
So you check 0, minus
Very
1, 1,
good,
and
very
then
good, very good.
you divide. Yes.
Yeah, yes. Trial and error method, you get one factor, and by division, you get the other factors. So at what points in this interval function sine 2x attains its maximum value? Okay, 8th question. What about 8th? Tell me then, 8th question, we'll do it quickly and then go for 8th question. Quick. What you should do? F of x equal to, let's say, sine 2x. Now you need to understand in this 0 to 2 pi, does the function attains its maximum? Question is this. Yeah, tell me. F dash of x is
2 cos
2 cos
2x.
2x.
2 cos 2x. Yeah. What you should do next?
Equate to 0.
Equate. Yes, sir.
Okay, cos 2x equal to 0, then x is what? 0 to 2 pi only you should check. X belongs to 0 to 2 pi. What you want is 2x belongs to what?
Pi by 2.
Very good. Pi by 2 and 3 pi by 2 and 5 pi by 2 and 7 pi by 2. Odd multiples of pi by 2. So x I want. What is x? X equal to pi by 4 and 3 pi by 4 and 5 pi by 4 and 7 pi by 4. Understand? Okay. 8 pi by 4 is what? 2 pi, till 2 pi. These are the 4 points. Is that okay?
Yes, sir. 1 second.
Yeah, here x is 0 to 2 pi, 2x is 0 to 4 pi. Till 4 pi I need to check. So till 4 pi I checked it. These are the 4 points I got. Now, at what points in the interval 0 to 2 pi does the function sine 2x attain its maximum value? Sine 2x graph is same thing. Sine 2x graph will be like this only. No? It will be like this. Same thing. Understand? Graph is same. That means what here? Here is your maximum. Here is but here no 2x value 0 to 4 pi. 0 2 pi only. This is no 4 pi. So 4 pi means what? 2 more. That means what? At 2 points you will have maximum, at 2 points you will have minimum. These are no 4 points are there. Substitute, that's it. If all 2x is there, na, you substitute. 4 points are there, you substitute. Simple. That's why at what points in interval does the function attains its maximum? So 2x value you substitute. 2x is what? Pi by 2. You substitute 2x pi by 2. Sine 2x is sine pi by 2 is what? Sine 2x is what? 3 pi by 2. 2x value I am substituting directly. Is what? Minus 4. Sine 5 pi by 2 is, pi plus pi by 2. 5 pi by 2 is 2 pi plus pi by 2 is sine pi by 2. 1. Sine 7 pi by 2 is minus 1. So at these 2 points, okay. So, but what you should do now? X equal to pi by 4, x equal to 5 pi by 4. That's what? Because 2x equal to pi by 2, na? X is pi by 4. This is 1 point. So, what are the points? Pi by 4 and 5 pi by 4. Because x value, at what points means what x value you need to find. Okay? 2x directly we have to put. Then if we get x, then that is pi by 4 and 5 pi by 4. Is it clear to everybody? Ashika,
Yes, sir.
Rishita, Meryl.
Yes, sir.
All right. So then what is the maximum value of the function? Okay, 10th question. Find the maximum in the interval and find also maximum value of the same function in this interval. That means 2 questions. See, maximum value of the function in this interval you need to find. This is 1 question, separate. Find the maximum value of the same function in this interval. Okay.